Hi, Assalamualaikum. My name is Nurul Izzah binti Aziansha and I'm from D1T3. So I'll be talking about 1.1 water and 2.2 the structure and functions of cell membrane and organelles. So let's get started.
So let's start with 1.1. Water. So the structure of water molecules. Water molecules consist of two hydrogen atoms and one oxygen atom, and its chemical formula is H2O. It is joined by covalent bond, and each hydrogen are separated by 104.5 degree. The next one is the covalent bond in water molecule. How covalent bond form in water molecules? So each oxygen atom has 6 electrons in its outer shell, and each hydrogen atom has 1 electron. Hence, each two hydrogen atoms share an electron with the O atom. Next, moving on to electronegativity. Electronegativity is a tendency of an atom to attract shared electron to itself in a chemical bond. The more electronegative an atom, example oxygen atom, the more strongly it pulls shared electron toward itself. So the next one is hydrogen bond. Water molecules are held together by hydrogen bond represented by the dotted line. So one water molecule can form maximum of 4 hydrogen bond with 4 water molecule. And in liquid state, water molecules continuously form, break and reform. Moving on to the properties of water. So there are 5 properties of water. The first one is universal solvent. The next one is high specific heat capacity, high latent heat of vaporization, cohesion of water molecule, and the last one is maximum density at 4 degrees Celsius. Moving on to the first one, universal solvent. So due to unequal distribution of electron within the molecule, they have the ability to form hydrogen bond with other molecule, and it makes them as powerful universal solvent against polar substance, ionic compound, and organic molecules. Next is high specific heat capacity. Its definition is the quantity of heat that must be absorbed or lost for 1 gram of substance to increase temperature by 1 degree Celsius. So why do water has high specific heat capacity? So basically, a lot of energy is needed to increase the temperature of water to 1 degree Celsius, and a lot of energy must be absorbed to break the hydrogen bonds between water molecules, and a lot of energy are released when hydrogen bonds are formed between water molecules. Next is high latent heat of vaporization. So the definition of latent heat of vaporization is the quantity of heat that must be absorbed for 1 gram of liquid to be converted to gaseous state. So why do water has high latent heat of vaporization? So basically, a lot of energy is absorbed to break the hydrogen bonds between water molecules to change from liquid to vapor. And due to hydrogen bond, it is difficult for water molecule to separate and vaporize. So moving on to the next one is cohesion of water molecules. The cohesive force enable water molecules to stick together by hydrogen bond. And attractive forces between molecules of the same type are called cohesive forces, while attractive forces between molecules of different types are called adhesive forces. And the last one is maximum density at 4 degrees Celsius. So above 4 degrees Celsius, water is in liquid state and it expands as it warms and contracts as it cools. And below 4 degrees Celsius, water becomes crystalline lattice and bonded to form maximum molecules. Now let's see the comparison of hydrogen bond in ice and liquid state. So basically, ice is less dense than water. Therefore, the hydrogen bond in ice is more stable compared to in water. And that is all for chapter 1. So next one is chapter 2, the structure and function of organelles. So there are 2 types of cell. The first one is animal cell and second one is plant cell. So the first organelle is nucleus. The function of nucleus is to control cell activities and cell division. It also stores genetic material, and it is the site of RNA synthesis and ribosome subunit assembly. Next is ribosome. The function of ribosome, it is the site of protein synthesis, and it also acts as enzyme that is known as ribozyme to catalyze the formation of peptide bond. Moving on to endoplasmic reticulum. So there are two types of endoplasmic reticulum. The first one is rough ER and the second one is smooth ER. So rough ER is in charge of intercellular transport of protein, and smooth ER is the site of lipid synthesis and is in charge in the detoxification of toxic waste. And it also the storage of calcium ions in skeletal muscle, and it also in part of metabolism of carbohydrates. The next one is Golgi apparatus. So the function of Golgi apparatus is that it is in charge in process, modify, sorting, package, and transport protein. And Golgi apparatus also form lysosomes. Moving on to lysosome. So there are three functions of lysosome. The first one is intracellular digestion, which it digests macromolecules which enter the cell by phagocytosis process, and also recycles cell's own organic material, which it digests old or damaged organelles to recycle organic material by autophagy process. And the last one is programmed cell destruction, which it digests the whole cell by autolysis process. Mitochondria. So the function of mitochondria is that it is the site of ATP synthesis or cellular respiration. Krebs cycle occurs in matrix, while ETC occurs in cristae. Moving on to chloroplast. So the function of chloroplast is that it is a site of photosynthesis, which light-dependent reaction occurs in grana or thylakoid, while light-independent reaction occurs in stroma. Chloroplast also stores starch in stroma, and chloroplast is not available in animal cell. And the last organelle is centrioles. The function of centrioles is that it organizes microtubule assembly during cell division, and it also forms the basis of cilia and flagella. And that is all from me. Thank you for listening.
Get kick.